everyone. So in my presentation today, I'm going to be talking about how we have integrated forestry data into our Tally whole building lifecycle analysis. I will say that most of our research has been kind of tangential to an actual project that we were working on in San Diego, where the client was absolutely grilling us on questions about biogenic carbon. So we really had to dig deep into the scoping of Tally and kind of understand where all those wood carbon credits were coming from. So this graphic is actually mapping out how biogenic carbon is allocating across our portfolio of Tally assessments. None of these orange bar indicators really reflect the post-process Tally data. I just like to start here because I think it really sets the stage for our baseline scenario of tracking biogenic carbon that does not account for upstream forestry practices. So I think general conclusions that we can come to about this is that we see here that our live sector is reaping the most benefit from the biogenic carbon credit, and that's mostly due to just the sheer scale of the projects and the construction type. You can also see here that our biogenic carbon credits do not often balance out to more than 20% of our total GWP, with the exception of that one outlier. And I think this graphic is looking at full life cycle impact. So we are seeing those major biogenic emissions at end of life. So that's just something to keep in mind. So this was really the project that was like the catalyst for all of our research that I'll be showing later on. It's a 240,000 square foot, 6-story lab building in San Diego. And the client really wanted us to compare the carbon impacts of a functionally equivalent mass timber, steel, and concrete building. And they were specifically interested in understanding the carbon offset savings that could be achieved through designing with mass timber. But I think for this example, it's important to note that the study did not include things like interior partitions or envelope. It only included structure and diaphragms, which for the mass timber option included GLULAMs and CLT mostly. And so it really made this study very sensitive to all of the upstream factors that we post-processed in later on. And I think you guys will see that in some of our later graphics. But it's really just due to the sheer mass of wood that was in the mass timber option. So I think that's kind of a good distinction to make. And it's also important to note that there is a concrete topping slab and steel bracing in the mass timber option. So we do see impacts from those materials. So this was our very first version of the study, which visualizes data exported straight from Tally. The variation across each scenario is really just due to the transportation means and distances being edited in Tally. And because of the massive amount of wood in the mass timber option, we see a really high sensitivity to transportation edits because basically every material in that option is being edited for transportation. But one of the things that we wanted to know that we weren't really getting from this graphic was how to account for the carbon impact associated with forestry practices. And our client was concerned with cost premiums that are often associated with certified sustainably sourced timber. So I think having that additional carbon metric to track was a really valuable data point for us, for the entire team. Okay, so essentially this graphic is showing how we looked at, how Tally tracks biogenic carbon through a wood product cycle. And we found that there's this large upfront credit during the product stage. There's some credit during the renovation stage, depending on material lifespans and like kind of the wood finished products that you're using and how often those get replaced. And there's also this biogenic carbon emission at end of life due to incineration and landfill. But it's also worth noting that wood products will have a positive module D value because when you get a recycling credit for the avoided burden of a new material production, you have to pass on any carbon left in the wood product to the next life cycle so that person can claim the biogenic carbon as a credit, which means that you actually end up getting a GWP burden. So I know I was really confused by that because usually module D is just kind of like beyond the scope looking at recycling benefits, and usually that comes up as a negative credit, but in this case it's actually positive. So basically all of this to say that we are missing the upstream forestry practices, right? And so when David Diaz from EcoTrust and myself would present this research together, we would often call the presentation Missing the Forest. And it's not to say that the forest is out of scope. It's simply saying that North American forests are assumed to be in a carbon balance, which I think is both the case and both not the case. It's very property and landscape specific. So there's a lot of stuff happening in upstream forestry that can kind of sway the results in either direction for whole building life cycle analysis. And the problem is that we're missing all of this product specific data that quantifies specific sequestration and emissions rates. And so due to this lack of data, LCA tools will neutralize upstream forestry carbon as a proxy or kind of like an average for North American forests. And then I like to show this graphic a lot because it's from the new carbon architecture book by Bruce King, because it kind of sets the expectation for how this data will be distributed. So you have your worst case timber sourcing scenario, which includes long transportation distances and an unsustainably managed forest. But what's concerning is actually how close this scenario is to a concrete design, a traditional concrete design. And then when you see the best case timber sourcing falling far below the line, the question is, what is everything in between and how our assumptions about forestry getting wrapped into this distribution? And what I've learned is that the data is very nuanced. I think, ecosystems, forests, nature in general is very complex, as well as humans and our practices. So it's just important to note that the answer is not simple. The data is certainly not simple. So ultimately, I think it's important to understand what the governing rules for biogenic carbon accounting are and where the net neutrality assumption comes from. So we have the ISO standards that set the rules for developing environmental product declarations, or EPDs, but then those EPDs are being governed by individually by product category rules, or PCRs. So in the case of the AWC EPD for North American softwood lumber, the EPD is being governed by the PCR for North American structural and architectural wood, and also the ISO standard 21930, which confirms whether the country of origin has a stable or increasing net carbon stock. So per UN FCC reports for North America, we can assume that the carbon uptake is equivalent to biomass emissions and that the forest carbon stock is at least stable. So this is kind of digging into some of our research with EcoTrust. So in 2019, we were introduced to David Diaz with EcoTrust, who had co-authored a research paper that sampled 67 properties across Western Washington and Oregon. And the forest conditions were estimated from a remote sensing data set, and that data was simulated under alternative management approaches for 100 years. 22 of those properties were actually FSC certified, and collectively the properties were intended to reflect both small and large parcel sizes, as well as sparse to dense riparian buffer zones. And so the two management scenarios that were studied were max sustained timber yield, which is just reflecting long rotation, and then max net present value, which is short rotation. And then the two sets of management constraints that were studied were State Forest Practices Act, FPA, or basically the state law minimum or code minimum, and then Forest Stewardship Council, which we all know as FSC. And so the landscape attributes that were simulated under these management scenarios were harvest rotation cycles, green tree retention, and riparian buffers. And obviously, there are a lot of other factors affecting forest health and sustainable management, but for carbon accounting purposes, these characteristics would be the indicators for forest carbon. So this was the second version of the graphic that I showed earlier, and this now includes all of our EcoTrust forestry factors. We left the transportation distances to tally for the tally. We just left them at the tally defaults for all scenarios, and instead focused on instead of focusing on like the actual suppliers, we just focused on the 8 forest management scenarios from EcoTrust. From their research. And I think the interesting takeaway for us was that the tally baseline scenario in the middle showed a net positive carbon impact, whereas the blue bar indicating short rotation FSC forests in Washington showed a substantial net sequestration. So you would think that longer rotation cycles sequester more carbon, but it turns out from like a stand forest level, more trees are actually retained during shorter harvest cycles. And so I like to say that the purpose of this chart is not to directly compare one scenario against another. I think it's meant to just contextualize the tally baseline within an array of other options. So, you know, we say that the forest has a stable carbon stock as a national average, but what are the individual properties telling us, and how sensitive are they to FSC or state minimum code practices? So in the previous graphic that I showed, the underlying forestry data was not exactly conducive to attributional LCA because it was factoring market effects leakage. And those kinds of projections aren't like, are more representative of consequential LCA. So in the second round of collaboration, David actually honed the data to include carbon stock changes that considers more than standing in live dead trees, and includes things like slash burning emissions, harvested carbon emitted during wood processing, and emissions during logging. But it's important to note that we're still not tracking soil carbon. So this led us to our final graphic, which we converted actually from a bar chart visualization to a box and whisker chart so that we could kind of illustrate the statistical range of each data set. I think with the bar chart graphic, we often found ourselves defending the intent of the study. A lot of times people want conclusive answers to say, okay, now I'm going to spec all of my wood from, you know, FSC Washington forest. And that's not really the intent of the study. The intent was more of a proof of concept to show the range of possible outcomes when you stop ignoring forestry practices. And I think overall, assuming a stable forest carbon stock is acceptable since we have limited data, but it does beg the question of how LCA tools will progress and kind of become more inclusive of a wider range of scenarios in the future. And what is striking to me about these data sets that I'm showing here in the box and whisker are the 95th and 5th percentile data points that show outlier conditions for short FSC in Oregon. It's just an example of how, you know, you might have your median value land just below 0, but your outlier conditions are wildly different and could potentially be more impactful than a steel and concrete building. So this overall has been a really interesting sensitivity analysis for us, and it has just reminded us to be super mindful about the forest product sourcing that we're writing into our specs, and kind of just to advocate, you know, for data wherever possible. We really need EPDs to be tracking, product-specific EPDs to be tracking this upstream biogenic carbon. So that is my last slide, and I guess now I can just pass it off to the ZGF and UW.